Okay, I will give some explanation. Okay. The point is, the purpose I give you this quiz early is to know what your level is. Okay. So at least I know and what can I do to support you. If you are really need like maybe. So let me describe the question. Okay. Number one. Let me just get you to the point here. Okay, this is not equal. Okay, this is not equal. Although you were going to cancel this out and you say, okay, this is also x. No, that's not equal. That's different function. Okay? We talk about function, I think, a lot in class. So when we talk about function, we talk about domain. So f is not equal to, okay? Okay, number two. Number two is about inverse. Okay. But first we need to find the domain. We have logarithmic. In logarithmic, everything inside needs to be. Can it be zero? No, right? So it should be positive. So we said that this one inside is positive. Then we get our interval of domain. Okay? And then we try to make this x inverse. Okay? Then we try to make out of x. So we remove the out and right. Okay? And then we just set up some equations. Then we get the inverse. Okay? And then of course we set the domain again, but now the exponent is always positive, right? Exponent is always positive. So domain is all number x. So all x is okay. So domain is for all real numbers. Okay? Number three. Remember, continue. Continue means limit left, limit right, the same, and then equal to its function. Okay? Equal to its function. You see this equal here? It means you can put 2 inside, and it's the function, right? The function value. Which means every interval we need to check. So check every interval, 2 from the left, 2 from the right. We get some sort of equation, that's okay. But we need to make sure that if we want that to be continuous, then this equation needs to be equal to this, right? Okay? And this is also equal to the function of 2, right? Then it's also similar. And we have this equations. And then we also have the 3 from the left and also from the right. I need to make sure that this is equal, okay? We just write the equation first, and then we need to have everything to be equal, and then we can set up the linear equations between these two. We set up the solution that A needs to be equal to half, B also half. So if we take A equal to half and B equal to half, all the function or all the setup will be continuous functions. Okay? And then evaluate the limit. Okay. Okay. I think I mentioned for some parts in class, every time you see the square root, you can rationalize. You can rationalize. You can multiply with this. Okay. And the idea is, after you multiply, you get this. And then this one, you can check left limit, right limit. And if you are probably confused on how to get this negative positive, you can try some numbers. You can try 4 from the left, 3, 2, 1, okay. Or maybe 3.5, but I think 3, 2, 1, 0 is okay. You said it was going to be going down, right? You check 4 from the right, so you check maybe 5, 6, 7, and so on and so forth. You will see that when you are taking this closer to 4 from the right side, you will get positive value, which means this is not equal, right? Or we can say that, okay, this limit doesn't exist. Okay, the last one is actually one of the typical questions for squeeze theorem. Okay, just multiply it. So we multiply, and then we get that the left side and the right side, we take limit, they are equal to 0. Of course, the middle one also 0. Okay, and that's your okay, any question about this? Okay, so hopefully, if I finish the grading, and if I check, and maybe if you need, maybe my suggestions, if it is too low, then taking tutors is, I think, one of the suggestions that I can give to you. Okay. Now, getting to our calculus, okay, our calculus class. So take also back to the notes. Okay. So this is last time. Okay, last time. Okay. So the next is about differentiable. Nanti pulang setelah baca. Oke. KKM-nya berapa lagi? Okay, so okay. So this is how the notation for differential, or the we say this is the derivative. We say derivative. So f prime, the first derivative of f, y prime, and then dy over dx. This is all the same. And you can write the derivative symbols like that. And see this some definition here. We say that the function will be differentiable if the f prime of a exists. So we need to make sure that the f prime exists, and then we say that it is differentiable on the open interval a, b, and then we say it's differentiable on open interval if it is differentiable at every number. So I would like to emphasize at every number. Okay. So every number. So what does it mean? Okay. If we need to check, okay, let's say for example, we have the absolute value. Okay. We have the absolute value of x. Now, based on these definitions, and we know that the limit definition of derivative from Tuesday class, that the f prime, we get the limit. Let me use the h definition. So this will be f x plus h minus f x over h. Okay, and then we can substitute the absolute value. But then we need to also, because it's absolute value, we need to set up which kind of x or which kind of functions. So remember that the absolute value of x, it can be just x for x is positive, right? And it can be negative x for x is negative, right? So now we have this f prime. So let's start from the positive one first. Then the f prime x this will be x plus h minus x over h. And then we can see that we can cancel x because of the subtraction. Then we have h over h, which is going to be 1, right? Now for the negative part, from x less than 0, we try to do the same thing, but we are going to substitute the absolute value with the negative, okay? So we are writing negative x plus h, and a negative x. Okay, I'm using brackets to avoid mistake and to help you view the process clearly. Okay, now we see that this first one here becomes negative x plus x and then negative h, right? So this one is canceling. So we get the negative h over h, which is negative 1. So it seems different, right? The first one on the right side is getting a positive value. On the left side, getting negative, okay? But we say that on the right side, all the numbers is differentiable. On the left side, all the numbers is differentiable. Then one way to make sure that this is differentiable on every number, then we can check x equals 0, right? We can check x equals 0. Then how to check x equals 0? So let me write this one over there. Let me write first here. So for x equals 0, it means that we are going to take the x equals 0 like that, and then limit as h close to 0, and then this f plus 0 plus h minus f 0, and then h. And it turns out, so we write everything here. Absolute value 0 plus h, let me write like that. And we get that this is limit as h of, and then we get the absolute value of h over h, right? If this is exists. Now because we still have dispute here, we don't know if it exists or not, we go back to our limit definitions, exist or not exist. So we check limit from the left of the 0 and right of the 0. Okay? So check left limit and right limit. Okay. So check limit as h, let's say from the right side. And as usual, this gives you the positive, okay, from the right. This is equal 1, right? And the second one, it's give you negative. So since this is different, we can write limit is not the same with the limit. So limit h closer to 0 this doesn't exist. So we can also write from these conclusions that the f prime 0 also doesn't exist. So we can write f is differentiable at all x except 0. And then we can also maybe write the f prime
it can be 1 or negative 1. This is for x positive, and this is for x negative. Okay, that is if we are using the limit definitions, okay?
Okay. So differentiable is not the same like you have derivative. You can still compute the derivative f prime using limit. But if it is asking differentiability, if it's asking differentiable, we need to check with another to make sure all numbers, they are all differentiable. There are a few notes for this differentiable, especially if you can draw the graph. If you can draw the graph and you can see some types of graph that it is not differentiable. For example, this absolute value like this, let me just explain for a little bit here. It's straight line, right? Straight line, and we know the slope, right? This is negative, right? Negative slope. And then the right one is positive slope. Okay? So if we zoom in
and then try to figure out the exact point at one point at this 0, what would be?
positive, negative, 0. We don't know, right? Because it's exact point at the pointy corner. That's the one that is what we say is differentiable. There is no slope on that point. That's why when we differentiate this, of course the line equation becomes just a constant, right? Become just a constant, which means that this is going to be like this. This is the f prime. Yeah, this is the f prime. So nothing in the middle. Right? It means that we cannot derive the functions at x equals 0. Okay? So every time you see any corner like absolute value, it means that at that point we cannot derive. There will be no slope. Okay?
And then, let me back here again.
The absolute value is a continuous function, right? So not all continuous functions can be differentiable. Okay? That's one thing.
But if we reverse the theorem, it say that if a function differentiable at one point A,
then it must be continuous. It for sure it should be continuous. Okay? Do not switch this, okay, because it will be false. Okay? Because we see that absolute value of x is continuous function, but it's not differentiable at every number. Okay? But if f differentiable at some point, it must be continuous at that point. Okay?
Okay, if you want to write the notes, you can write.
If you remember the question before from the quiz is still asking the continuity. Maybe another time the question will be asking about differentiable. The idea is still the same, but you need to add the limit definition of derivative.
Okay. Okay. Any questions first?
Differentiability. Now this part is actually a transition to differentiation rules that we are going to learn. So we're still in the limit definition of derivative and differentiability.
Okay, now, okay, there are at least three cases.
So we say it's failed to be differentiable. A corner, like the absolute value, you have a corner, a pointy corner, and then of course this discontinuous, right? Discontinuity can also be we fail to be differentiable. And another one is the vertical tangent. We say it's not differentiable. For the vertical tangent, it's not differentiable because this tangent, if we think in a slope, that will be infinite slope, right? You can think like that. You know the slope zeros like that, and then how about if we are making it straight line vertically? It means that it's going to be infinite slope, which is not exist, right? And then we can say that it's not differentiable.
We cannot differentiate at that point. Maybe let me write here as just a note that this one here is limit for the f prime is infinity. So the slope is infinite. Okay, let me write here. Let me make some title. Differentiation rule. Okay, first is the easiest one. That if you have a function that is just giving you a constant, let's say it's a constant. Then if we take into our definition of limit for derivative, then this is just a constant minus constant over h, which gives you 0. Or maybe to make sure that we understand the limit concept, we need to write that it's subtraction first before we goes by this. Okay. So it's not 0 over 0. So it definitely goes 0 first before we touch the limit. So this will be 0. So we can also write with the Newton or Leibniz notations, ddx of c is 0. Now how about if we take, for example, let me just try polynomial. Let me check this x with power of 4. This, so if we take the limit definition, or maybe it will be a little bit long. So we exchange all with x plus h with power of 4. Okay, this is also reviewing our binomials. Okay, I think this long. So x plus h, x4 plus 4x cubed h, right? And then 4, 6, and this should be equal to 2, and then 4xh cubed plus h4. Okay, it's longer. Okay. And then minus x with power of 4. And we can cancel this part. And the other part, we can factor out h. So we have 4x cubed plus 6x squared h plus 4x h squared plus h cubed. Now we can cancel this, okay? And then the rest
is basically taking h for each part 0, 0, 0, so we have 4x cubed.
okay? So this is the way if you want to prove that we can derive x with power of 4 and then become 4x cubed. And later you can check x to the power of 5 if you want, or x cubed, x squared. They will give some patterns. Okay? They will give some patterns which you can recognize easily. Let me write on below here. Let me resize a little bit. So we can write that if n is a positive integer, then d dx x to the power of n, this is n, x, n minus 1. Okay, and I think I can give also another statement, okay, that conclude everything. So n is not only for integer, actually. So if you take some time to prove it, n can be any real number. We can prove this by, but I don't think I can have much time for proving this. We can start by taking this. So this is f is equal to x with power of n. And then by taking the expansions, basically doing what we have
In here, you could see some patterns.
that I think some of you maybe have learned before, and we can write at this part here, and then we can actually factorize and then canceling the x minus a, okay, and then we can simply say that we can exchange x to a, so a n minus 1 plus a n minus 2, a plus plus a n minus 2 plus a n minus 1. You see that
The first one compared to the last one is the same. The second one and the second last is the same. And if you are making more and more in the middle, you will see that they are pairing with each other, which means that we can multiply some n numbers with them to complete them, right? To compute all of them.
Which means that this is going to be n of the a n minus 1, right?
So a put here is n minus 1, right? This is also n minus 1. And you will see that if we pairing all of them, they are becoming a n minus 1. A n minus 1 plus a n minus 1 plus plus. For some n numbers, we can just say n multiplied with this a n minus 1. Okay? And then this proving that all n
can be also proven that we can do this for every real number of n. Okay. I'm not going to emphasize much on the proving. Okay, I hope you get it. And if you want to know more, maybe I will leave the some more explanation about that in maybe additional informations. But for now, you see that we can derive the power, okay, the power rule. Okay. So this is we call this the power rule. All right, let me give you some sort of notes. So basic derivative rules. So if you have a constant c, okay, constant c. So c is a constant. Then basically we can focus only on the functions. Okay, we can just split like that. And then if we have addition inside the derivative, or even subtractions, the same behavior, we can separate them like this. Okay, this is G. I hope you're already familiar with my G. Not very usual. Usually people write G like this, right? But sometimes I confuse that part with 9, so I prefer this one. Okay. And also 2 rules that perhaps will be very important, because I think for most of the case in the future you will use this for most cases. So let me write first and let me explain how we get this formula. Okay? So this f of x, g of x, and then this becomes f prime x g of x plus g prime x, and then f of x. And then we have also the quotient rule. Which is f over g and then we have f prime x. To avoid mistake, let me write like that. Okay, I'm not suggesting to memorize this, but it will be easier if you memorize. Okay? I think I have time for the product rule. So let me explain how we get this formula. Okay. So let me move to another slide. Let me copy. Now, to make this formula, let's start with defining a function with a capital F like that. Okay? And it's not the same with the small f. Okay? So let's define this as a multiplication of small f and g. Okay, we define derivative, okay, using the, let's say this one. I'm using the h1, sorry. So we have f x plus h minus f x, like that, and divide by h. Okay. And now substitute the f, the capital F, with the multiplication fg. We have f x plus h g x plus h minus fx gx. And over h. Now what will happen now? What's the idea? How do we get to solve this? So to make some sort of simplification of this limit definition, let's say we add and subtract, okay, with some elements, that when that elements compose with this, combine with this, we can make some definition through this limit. Okay, so the idea is, so add and subtract fx plus h and then multiply g of x. So why we need to add this and subtract this? Okay, so let me just write first. Okay, so limit so this is fx plus h, okay, and then let's add this and minus same one, like that, and then minus
now what's next? The next one is we are going to group. We are going to group fx plus h and g of x. You can do the same thing if you exchange g and f. You can do the same thing, but you are grouping g with f. But now we are grouping the fx plus h and gx. So we are separating them.
So let me write here, grouping the fx plus h and g of x. So this limit becomes fx plus h. So factorize. So this will be gx plus h minus gx over h, and then plus limit for g. Okay, and then gx factorize. This is fx plus h minus fx divided by h. Okay, now we can try to separate all the limit. Okay.
Now, this limit from the left, if we look at the fx plus h, it's just f of x. This becomes derivative of g, right? The definition of g. and then this is G, and this is the F prime. Okay.
So we get this is fx g prime x plus gx f prime x. So this will be, so this is g prime, this is f prime, this is gx, right, and this is fx. Okay, this is, I think, intuitively how to get this product rule. You can also use the, in your textbook, you can see it's using the rectangle in geometry to prove the product rule. Okay, so as for an implications, for example, let's start to take some time to practice this. So if you have a function, oh, exponent, we haven't learned exponent yet. Maybe change senses. Exponent will be next week, I think. Let's say we have this, okay, and then g of 4 is 2, and g prime of 4 is 3, and then f prime of 4 is dot, dot, dot. Okay, remember, let me write on the right side as a note. If you have the roots, okay, remember the roots. Like for example, the square root means that x is power half, right? So when you try to take derivative of that, so remember we pull down the half going here, and we take -1, right? So it's become negative half. So we can write, okay. So this is the derivative of the square root of x. Now we do want to have the f prime 4. So if we take the f prime x, it means that we're taking the whole derivative of the square root of x and g of x, which means that we take like that, and then we take like that. Okay, so we get this will be square root of x, and then just write g prime x, okay, and then plus g of x, and then 1 over 2 square root of x, like that. So this is f prime x, so f prime 4 is 2 g prime of 2, sorry, not 2, 4, sorry, and then plus g of 4, 1 over 4. So g prime of 4 is 3. So this is 3. This is 2. So 6 and half. So 6 half, or let me just write 6.5. Okay. That's one example, and I think I would like to end the lecture up